Okay.
Right?
Awesome. GM everyone. This is YH, Education Partner at Moledao. Moledao is a blockchain ecosystem builder with the aim to empower everyone in the blockchain space. We recently launched our NFT 2.0 hackathon, and we welcome each and every one of you to join us, especially if you're a builder excited to build in this space. For more information about Moledao and our ongoing NFT 2.0 hackathon, please click on our YouTube description below and click on the Discord link to join our Discord to find out more. Today, we have specially invited Raj Karia, Community and Talent Lead at Questbook, which is a developer-focused community, who will be sharing with everyone here on how to write and deploy an NFT smart contract. So don't worry if you don't really know Solidity, because Raj will be giving us a quick crash course on how to, code in Solidity before starting as well. Thank you, Raj, for joining us today. And if you have any questions, please feel free to type in the YouTube chat box. We will pick your questions later and get Raj to help to answer them. So without further ado, let's start learning with Raj. So thank you, Raj. Please feel free to start your session now.
Yeah, thanks for the great intro. And again, thanks to entire Moledao team and you to host this session. So without wasting any more time, we'll quickly start with coding and get our hands dirty, mint an NFT. So before we start, I want to tell everyone what an NFT is, right? So what the word NFT means. It's non-fungible token. So what do you mean by non-fungible token? It's a very fancy term, but when you break it down to a single terms, right? Fungible means anything that could be changed. That is what fungible is. It could be a fungible asset. It could be a fungible thing. Fungible essentially means the things that could be changed. So now when you add a known to it, it means that the things which cannot be changed. Another word for it would be immutable. So now you know non-fungible token means a token which cannot be changed. So when we understand it with blockchain language, it will be a token which is non-fungible, that is immutable, which means once minted, you can't change it. So we'll now go into the details of how you could actually implement a non-fungible token if you want. So let me quickly share my screen. Yeah, is my screen visible? Could you quickly give me a GM in the chat if the screen is visible? All right. So for those of you who don't know, we'll be using Remix, which is an online compiler for Solidity. And Solidity is the language in which we'll code. Usually all the EVM-based chains uses Solidity as their go-to language. So we'll be focusing on Solidity and we'll be minting our NFTs using Solidity. We'll write a smart contract to mint our NFTs. So let's get started. So firstly, what we'll do is let's create a new file. Let's name it Moledao NFT. Moledao NFT.sol. .sol is the extension of all the files in your smart contract. So now, before starting a Solidity smart contract, we write two things. One is pragma Solidity, and then you define version of Solidity. So let's say we'll be using 0.8.11, which is the latest version of Solidity. This is the latest version of Solidity. So now why do we write this thing? Okay, before going forward, let's just understand this one thing. This defines that we will be using this version of Solidity, 0.8.11. So if you're using some functions or some nuances of 0.8.10, those won't work here. The reason being, smart contract, once minted, can't be changed, it is immutable, which is an inherent feature of Web3. So now the language itself is constantly evolving. So meaning of one variable, meaning of one term today might be different tomorrow. So we'll always tell our smart contract that, hey, use this version, use all the conventions of this version for this smart contract. So it doesn't matter if tomorrow there is 5.10.11 something version, but we'll tell our smart contract that no matter what version comes, no matter what happens, you will only use this particular version. And we use this also because Solidity is constantly evolving. You could understand by the fact that we are still at 0.8. It's not even version 1. We are still at 0.8.11. So we are very early. And because of that, it is constantly changing, constantly evolving. So we'll use this. And because of this reason, it is you won't find any books on Solidity. Because by the time you write a book and you publish it, the versions will be changed and the knowledge will be useless. That's why there will be very little books, very few books on Solidity. Best way to learn Solidity is using documentation and GitHub repos. So I'll quickly share documentation of Solidity so that you guys could learn. If you want, just type Solidity docs, you will get something. Yeah. Okay, the latest is 0.8.12. Even I was not updated. Yeah. Last I visited, latest was 0.8.11, but now it is 0.8.12. So that's how fast evolving Solidity is. So this is the documentation of Solidity. You will find everything over here. Everything that we'll use today will be over here. And if you want any version specific documentation, you could just click over here and you will get version specific documentations. All right, then let's start our smart contract. So you, before starting, you might have, if you have coded in Python or JavaScript, you might have come across this thing called packages. There are certain packages which will do some things. In JavaScript, there are authentication packages. There are some libraries which you could use, like let's say Bootstrap for CSS. And in Python, there are certain packages to do all the kind of things. Like Python is a house of packages. So we have something similar in Solidity also, because it's virtually impossible to write each and every code. So we have created some packages. These packages are called Open Zeppelin libraries. That's what we call them. So you go to Open Zeppelin, and you will see once you go to Open Zeppelin, you will see all the contracts that are being written by Open Zeppelin library. If you go to docs, and we'll directly use these contracts for certain use cases. You see this? npm install Open Zeppelin contracts. So this will install all the smart contracts that you want, and you can then directly use those functions. Instead of writing each and every line of code from scratch, you could use this. So Open Zeppelin also has this interesting thing called Open Zeppelin Wizard. It's like a drag and drop tool for you to learn Solidity, for you to write smart contract. So go to wizard.openzeppelin.com, and over here you will find this drag and drop tool. Now we'll go through how it works. But before we do that, the first thing that you see while coming over here is this ERC20, ERC721, ERC1155, and governed. So what are these things? These things are token standards. So the Solidity is a language, and smart contract is like globally. Once you write a smart contract, it is globally acceptable. So you can't write a globally acceptable smart contract if there are no standards. Otherwise, like I will write something, another guy will write something, someone else will write something, and it will all get messed up. So to maintain the discipline, we have this thing called standards. So ERC20 standard has a certain set of rules. You need to follow that rule, And by following that rule, if you create a token, it will be called ERC20 token. ERC721 is also standard. It has certain rules. So if you're creating a token following ERC721 rules, you are creating a token that will follow this standard. Likewise, there are multiple standards, ERC721A, B, C, like there are multiple derivatives of these smart contracts. We'll learn each of those in detail. But to start with, we'll go deep dive into ERC720. It is the basic smart contract to mint any NFT. Once we learn ERC720, we'll probably also learn ERC1155 in future sessions. So what is ERC721? ERC721 is, okay, let me just show you in the documentation. Yeah. So yeah, once you go into documentation, you will see this ERC721 docs. Over here, all the things that are there in this smart contract are mentioned. If you click on API references, you'll get all the API references that ERC721 is using. We'll come to each one of these API references. We'll use each one of these to start with. But before that, let's just go to our wizard and see what it has to offer. So first thing is, there are these fields that you need to fill, and it will give pre-populated smart contract, so that you don't need to write these redundant things each and every time. So let's say the name of my token, it will be name of your NFT token. Let's name it MoleNFT, and the symbol will give it as MNFT. So over here, the name and symbol references. Let's say if you are taking Bitcoin as an example, then Bitcoin is your name and BTC is your symbol. Similarly, if you take Ethereum, then if you take Ether, then Ether is your name and ETH is your symbol. So over here, we are creating a token with the name MoleNFT, and the symbol will be MNFT. And then there is this thing called base URI. This is where all your images and metadata will be hosted. We'll learn what an image, what an metadata is. But for now, for the sake of simplicity, let's just assume that this is where everything will be hosted. So let's write something like Moledao.com. Okay, this is where all our images and metadata will be residing. So now you see, we have this basic structure that we have Pragma Solidity over here. Then we are importing this ERC721.sol because we are using ERC721 token standard. That is where we are importing ERC721.sol. And then we are creating a contract. So to start any smart contract, we use the keyword contract in Solidity. So we are creating a contract named MoleNFT, which is the name of this NFT. And over here we'll say is ERC721. This indicates that we are inheriting our smart contract from ERC721. There are certain predefined functions in ERC721, and we will be using it. This is the concept of inheritance. If you don't know, you could go to Solidity documents and learn inheritance from here. We won't go into much details. If we go, then we'll never be able to complete this session. And yeah, now we'll see a base URI. This is base URI because we'll be adding things on top of it. We'll come to that later, but for now, let's just understand that base URI is something. We'll have something like this. Something like this. moledao.com/nft/1.jpg. So if you click on this, you'll probably find 1.jpg. So over here, your moledao.com is your base URI, and this is your mint URI. Let's call it mint URI. It will indicate where your address is located. Okay. Okay, let me just. In just a minute, I'll hide this Control Z. Yeah. So far so good. what you have done is you have created a name, we have given it a symbol, and then we have added a base URL. So now what features do we need? We need it to be mintable, that someone should be able to mint these NFTs. So that's why mintable. Then we want to have auto increment IDs. That means that we don't want to manually burden about having IDs. Auto increment will start from 0. And it will keep on auto incrementing 0, 1, 2, 3, 4, and so on and so forth. Then burnable means if you want to burn an NFT, you could burn it with the smart contract. For the sake of simplicity, let's not use that. Pausable means you could pause your smart contract in between. Like this is the feature of blockchain that once you deploy anything on mainnet, right? You can't just go back. But then that doesn't happen in real life, right? In real life, people tend to make mistakes. Shit happens in real life. So that's why we have this pausable function, which will pause your smart contract for the time being. You can't stop or destroy your smart contract, but you could pause it so that you figure out that now what should be the next step to make sure that our smart contract is safe, secure, and sound. So this is a pausable feature. For the sake of simplicity, we won't implement pausable feature. Then there is the enumerable feature. We'll implement enumerable because we want to have NFTs which will have auto-incremented IDs, and hence enumerable is a really great feature to have. We'll learn what it means in detail. Then URI storage. This is again, we discussed about URI, right? That if you want an URI, we'll store all our images on our URI. So this is regarding that hey, this token ID will reside over here in the blockchain. And then access control, enable and rules. For the sake of simplicity, let's just keep it rules. Let's just keep it enable. Let's not go into rules. We'll come to that later. Then upgradability. So this is a new feature that has been included in blockchain recently. So previously, if you deploy a smart contract, you couldn't change it. You couldn't upgrade it. Once it is deployed, it's done and dusted. There's nothing you could do. But now there's a feature called proxy, with which you could update your smart contracts with certain constants. So this is regarding that. Upgradability makes a smart contract very complex to start with. So we won't learn about upgradability for now, but in future sessions, we'll definitely learn upgradability because this is the technology of future. This is how smart contracts will be written from now. So yeah, so we have a basic smart contract template now. Let's see what all things we have. First thing is we are importing everything, all the ERC21 standards and everything. Then we have a smart contract named MoleNFT, which is inheriting all these things. ERC710, enumerable, URI storage, enable. These are the smart contracts, okay, predefined smart contracts. We are importing them over here, and this defines that we'll be using these libraries in our smart contract. Then there is counters. It is because we have made it auto increment IDs. So that's why this will take ID and then it will counter, auto increment it each and every time. Then there is a constructor. A constructor is something which will be executed first when you deploy an NFT, when you deploy the smart contract. So what happens in a lifecycle of smart contract is you write a smart contract, you deploy it, and then you call it. Like this is what we usually do. We usually call our smart contracts, but deploying could happen only once and only owner could deploy it. So that's why we said all the basic things which should not be repeated in our constructor. So that whenever our smart contract is called, we simply, all these things will be executed. And now when the next time when we call our smart contract, we don't do these redundant processes again and again, because everything in a smart contract, everything is chargeable in smart contract, right? There's nothing like free things in smart contract. And if you want to do a smallest of transaction, you need to pay gas. So we make sure that we have all the primary requirements and all the redundant things in our constructor so that we don't execute those time and again. So that is what a constructor is. Then there is function. This base URI, safe mint, all these functions are from Open Zeppelin. we will see what the safe mint is, what this before token transfer is. All these functions are defined in our Open Zeppelin smart contract. So let's try to see how they are defined. Right, let's say it was safe mint, right? Yeah, safe mint function. So let's try to find safe mint over here. Where is it? Safe transfer. Okay, here it is, safe mint. So when you click on safe mint, you will see internal function to safely mint a new token. Reverse if the given token ID already exists. If target address is a contract, it must implement. So that means that if the target contract is, if target address is a contract, it will definitely execute this safe mint function. So what does that mean? Let's learn. Safe mint means it will mint your token to this address, address 2. So address to address is a data type in Solidity, which has your EVM addresses. Okay, the EVM addresses comes with a pattern. So each and every time validating those addresses doesn't make any sense. So we have an EVM. So we have a data type called addresses to address all the addresses. Funny as it sounds, but that is what it is. Then there is string memory URI. That means that the token that is lying in this URI, we want to mint it to this particular address 2. So we'll go into detail. So for now, let's just copy this entire smart contract and go to Remix. This is where we'll paste it. So yeah, so we have this entire smart contract with us. So there are no errors. You see, compile Moledao NFT.sol. It is compiled. You run it, it will even run. But for now, let's not run it. So let's understand. You might have seen many NFT drops, right? So what are the basic things that an NFT drop contains? Let's try to list out those things over here in comments. So what are the basic things that you see in an NFT drop? So the first thing is we'll see price of NFT, that is mint price. So let's say there is mint price of an NFT. Then there will be a maximum supply that 10,000, 1,000, 7,777. There are crazy numbers these days. So let's say max supply. Let's say max supply of NFT. This is the max supply that we have. Then we have certain features like a single person could only mint, let's say, 10 NFTs, not more than that. So we could say individual supply. Okay, this means supply for an individual supply. Then if you're minting an NFT, you need to withdraw the funds too. Right, like let's say if I'm creating a collection, I'm enabling 10,000 NFT mints. So whatever funds are collected, I need to withdraw that too, because right now the funds will be with this smart contract. So I need to withdraw those smart contracts to my address, to my wallet. So it also have a withdraw feature. Then there is whitelisting feature. Whitelisting means that there will be certain people will be getting primary accesses. Okay, before even the mint is live. Let's say if the mint is at 9 p.m. today, then by 8 p.m. these guys will get access. That means that let's say for collections of 1,000 NFTs, then 100 NFTs will be getting whitelisted. That means these 100 NFTs could be minted before the mint is live. So that is what whitelisting is. This is basic feature. Yeah, I guess this 5 things. If we implement these 5 things, we are good to go with a smart contract. We could interact with it. We could create a NFT collection of our own. So let's now deep dive and let's implement each one of these features. So firstly, I want to set my mint price. I want to set it. Okay, like I don't want to change my mint price. So what I'll do is I'll create a variable UN mint underscore price equal to, I'll name my price over here, okay? Let's say 0.1 ether. Okay, this is what we are mentioning. So we did three things over here. In this one line, there are three things that you need to notice. First thing is we have used this keyword called uint, that is a data type. It indicates that this variable will have values which will be uint, that is unsigned integer. So what is an integer? An integer is any number, negative, positive, or zero. And what is unsigned integer? An unsigned integer is something which has only positive integers, no negative integers. So since there is no concept of negative integers in Solidity, we always use uint. We'll never use int. Otherwise, this is also possible. Uint mint price. But then this doesn't make any sense because this will take more space and hence more gas fees. So we'll try to optimize our smart contract for gas also. So because of that reason, we'll be using uint. So here we are just setting our variable as uint data type. And another thing to notice is we are using this in capital words. So all your global variables should be written in a capital in all caps format. This is not a compulsory condition as such, but this is a convention that we follow, a coding convention that we follow to make our life easier. So that if anyone is seeing your smart contract, they could know that, hey, this is a global variable, this is where it will be used. This is that we use, just like standards, right? We discussed that we need some standards to bring calm to the chaos. Otherwise, like if everyone starts writing their own standards, we will go nowhere. And then we use this. Now you might be under this confusion that we are using uint, but then we are writing over here in decimals. 0.1 is a decimal, is a float, right? So why is it that happening? Ideally, an integer shouldn't have these decimals, right? Doesn't make any sense. We are just contradicting with our hypothesis. So this is not in point, right? We have used this keyword called ether. So ideally, in your smart contract, all the values are mentioned in ways. Okay, WEIS, ways. This is how all the values are mentioned. So this 0.1 ether, it's in the back end, it is interpreting it as way. And one way is equal to 10 raised to minus 18 ETH. That means that 10 raised to 18 ways equal to 1 ETH. So when we're writing 0.1 ether, okay, let me just write it. 10 raised to 18 way equal to 1 ETH. Right? So that is why when you're writing 0.1 ether, your smart contract will interpret it in ways. And this is equivalent to writing 10 raised to 17 ways. But for the sake of simplicity, we won't write in ways because ether is the normal convention. So we'll stick with 0.1 ether. We won't write with ways or anything. This is one thing. Okay, let me just remove this. So what we did is we established our mint price. So now next thing we want is max supply. So again, uint max supply. Let's keep our max supply as 100. Yeah, 100. Let's keep that. We want to mint 100 NFTs only. After 100, you can't mint anything beyond 100. Then individual supply. Uint individual supply. So let's say our individual supply is let's say 5. I don't want anyone to mint more than 5 NFTs. This is what our individual supply is, right? Then withdraw whitelisting. Okay, we'll go that as and when time comes. All right. So what we did, we have written certain variables, that this is what mint supply, mint price is, this is what max supply is, this is what individual supply is. We just declared our variables. So now let's use those variables, right? So your safe mint function, this is where the minting will happen. So let's say if you want to add some price to your NFT, you do that while minting your NFT, right? That's how it should be. That whenever you're minting, it should check whether the price is 0.1 ETH or not. So we'll add all these conditions over here. Okay, that before you mint, I want these conditions to be fulfilled. That's why we'll be writing all these things over here. So first condition is our mint price. So how do you define your mint price? So if you have gone through Solidity, there is this thing called require. REQUIRE. This is a required, I would say, method which checks certain conditions. Let's see how it goes. So what we require is, we require our message.value. Again, in Solidity, whenever you interact with a smart contract, you'll always do some transaction. And this transaction value, you fetch that value by message.value keyword. This is the default keyword of Solidity. So this returns you the value that your smart contract, the value that is that your smart contract is, or your address or a transaction is requesting. This is what message.value returns. So the value that it returns must be equal to mint price. Right? This is our condition. If this is fulfilled, then go ahead. If not, then throw an error. Is okay. Let's say mint price. Let's just use NFT lingo. Mint price not matching. As simple as this. Okay, spelling mistake. All right, as simple as this. So this means that if your transaction value is not equal to 0.1 Ether, it will throw an error that mint price is not matching. So now you'll always need to have 0.1 ETH. You need to do transactions with 0.1 ETH only. Only then the transactions will go through. Then again, if this happens, okay, if this condition is fulfilled, we want to have now another condition, that is max supply. Before max supply. Let's say, okay, let us write a comment over here so that it is, once we share this, is useful. Setting mint price of NFT. Then again, now what we want to do is checking max supply. Checking max supply. So how do you check your max supply? So what do you mean when you hear the word max supply? What does that mean? So there are two things, right? When an NFT is getting minted, one is the number of NFTs that got minted, and other is the number of NFTs that are about to be minted. So the sum of both this should be less than your max supply. Oh, also we could have another thing that is number of mints. Number of mints. This means that if I want let's say 2 NFTs, then I could request 2 NFTs. If I want 5 NFTs, I could request 5 NFTs. So interestingly, yeah. So now let's check. Let's create a condition. So what should the condition be? The total number of NFTs that are minted plus total number of NFTs that I'm requesting must be less than max supply. Right? Let's say there are 100 NFTs and 99 NFTs are minted. And if I'm requesting for 4 NFTs, then that request shouldn't go through, because 99 plus 4 equal to 103. So that exceeds my max supply. My max supply is only 100. So what do I need to check? I need to check that the number of NFTs that is already minted plus the number of NFTs I'm requesting is less than max supply. So how do we write that in our smart contract? Let's see. So first is number of mints. Okay, let's just define number of mints over here itself. End number of mints. Right? This is because we need to pass that variable in the function to tell our smart contract that hey, this guy is requesting you 3 NFTs, 4 NFTs, so mint accordingly. So we'll need to give that to our safe mint also. That hey, this guy is requesting you 5 NFTs, so mint accordingly. Or let's say, let's not tweak our mint smart. Let's not tweak this. Let's just write something like this. Let's create a new function called mint NFT, which will take end of number of mints, and then it will take address just like our safe mint, and then it will also take string memory URL. Also take URL. Yeah. Let's just say we have this thing. Okay, let's make it public, and then it returns nothing. Okay, what's the error? Okay, yeah. All right, so this is a function that will mint the requested number of NFTs. So now what SafeMint does? Okay, first thing is we check mint price. So now we want to check max supply. Okay, so what we'll do is we'll check max supply, require let's say number of mints plus the total NFTs minted, right? That is what we do. Take a common mathematical example. Let's say there are 100 NFTs, 99 are minted. I'm requesting 4, so it exceeds max supply, so it shouldn't go through. So that means number of mints plus total number of NFTs which are minted. So that total number you could get with this function called total supply. There is this function called total supply in your smart contract and in Solidity, which returns you the total number of tokens minted by this smart contract. So now number of mints plus token supply must be less than max supply. This is what it is. It must be less than your max supply. Or it should be less than or equal to, because less than or equal to, because 99 are minted, and if I'm requesting for 1 NFT, then it should go through. But in that case, 99 plus 100 will be want to be less than 100 as per our condition. So it should be less than or equal to max supply. So if this condition is not fulfilled, we'll say requested more NFTs, more than available NFTs, right? So this is what we are doing. So if this condition is not fulfilled, we are saying that hey, you are requesting more than available NFTs. So kindly make a justifiable request. So now what we did is we did max supply, we did mint price. Now individual supply. So how do you check individual supply? That is, let's say I'm minting 1 NFT right now, and then I'm minting 3 NFTs again. Then it should be done, right? I should be able to mint because 1 plus 3 equal to 4. But let's say I minted 1 NFT, and now I'm trying to mint another 5. So 1 plus 5 equal to 6. So now I should not be able to mint NFTs. So we will again write a required condition that will have this will include balance. Balance of there is another function called balance of, and in that you write address. Okay, balance of address. So this will give you, this will return the balance of this address for this token. So balance of 2 is less than, let's say, max individual supply. Yeah, it's less than individual supply. So far, are there any questions? Anyone? Any questions so far? I hope we are going good in a smoother pace. All right, perfect. Yeah, let's get started then. If this condition is not fulfilled, we'll say asking for more than allowed NFTs. Okay, this means that this guy is asking for more than what is allowed to. So once this is done, okay, what we'll do, we'll just mint our NFT. So now for minting, we want we want to mint 5 NFTs, right? Let's say we want to mint the number of NFTs which are equal to this. So what we do is, over here we'll run a for loop. Okay, our for loop will be let's say u int I, it will be, let's say, equal to 1, and then I is less than number of mint, the number of mint, and then I plus plus. So what we are doing, and over here we'll call safe mint, right? We could call our safe mint, and we could give our address, let's say address 2 and URL. Simple. So what just happened? Okay, let me remove this. So what happened? What happened just now? It is what we are saying our smart contract is that this is we want 5 mints. I am requesting you. I want 4 NFTs. So until and unless number 4 is reached, right? You just mint one NFT after the other. So this will say integer I equal to 1, I less than number of mint. So if you know normal for loop, it will keep on executing till I is less than number of mint, that is I is less than 4. Okay, so in that case, we'll need to write I equal to 0. Yeah, okay, well, let's say equal to 1, and over here we'll make less than equal to. So this means that until and unless till the point I is less than or equal to number of mint, it will keep on going and going. It will keep on executing whatever is inside your for function, inside your for loop. And what is inside your for loop? Inside your for loop is your safe mint function. Right? So now what you are doing is you are calling your safe mint and you are executing it. Since we could also have it as underscore safe mint, so that it directly executes from the function. And then we could add, okay, we could have all these conditions in our mint NFT function. Yeah, over here. This makes sense. So that before even checking, before even going through one, we'll be doing this thing. Why did we write? Why did we check these conditions over here and not here? Can anyone just guess? Yeah. Okay. Let me tell you. Because if we kept it under this safe mint function, what would happen? What would have happened is that every time this loop is running, it would have checked for all these conditions, which is redundant because we don't want to check these conditions every time one NFT is minted. If I'm requesting for 4 NFTs, I want these conditions to be checked only once. I don't want it to be checked 4 times. So that is why we do this. We just pasted our domain number of mint. Okay. Yeah. Yeah. All right. So this is what it is. So now when you run this mint NFT smart contract, it will execute this and it will mint your NFTs until and unless this condition is fulfilled, that I is less than number of mint. Okay, why is this error? Required number of mint plus. Okay. Okay. Here is a small issue. Yeah, spelling mistake. Spelling mistake is probably the worst enemy of a coder. Yeah. So we'll just do this. We'll just paste this over here. Yeah, perfect. So now we have a smart contract with which you could mint your NFTs. Are you getting it? Public, and let's make it payable. Okay. Are you getting it? So till now, what we have done is we have created a smart contract where you have defined that this is the mint price of my NFT. This will be the max supply. This will be the individual supply. You can't mint more than this, and this is how we will mint it. So now let's move on to another thing. That is withdrawing, right? Here we did mint price, max supply, individual supply, number of mints. So now let's come to withdraw. That yes, we minted our NFTs, but how will we withdraw that amount, right? So for that, let's just write a new function called function withdraw amount, withdraw mint amount. Withdraw mint amount. Let's make it payable. For the sake of simplicity, let's make it public. Okay. So what do we do with withdraw? With withdraw, what we do is that we want our smart contract to withdraw everything to our address. So right now what's happening is when we say that NFT is being minted, it is minted in the smart contract, in this smart contract. It is not in your address. This smart contract is holding all the ethers that were received by minting the NFTs. So to get those ethers in your account, you need to withdraw those. Okay. So how do we withdraw? There's this function called transfer. I don't know if you guys know it. Sorry, let me just have a sip of water. Yeah. All right. So there is this function called transfer. With transfer, what you could do is you could transfer whatever the amount you want to the addresses you want. Okay. So let's take a simple scenario first, and then let's take a complex example. So simple example would be I want to withdraw entire amount for myself. So what I do is transfer. So do you know how to use transfer? Anyone? Could you comment it down on YouTube in the chat and tell me how to use transfer? All right. How to use transfer is firstly you give the address where you want to transfer. So let's say over here we'll be giving address of owner, right? Address of owner. So now we want to transfer owner dot transfer. Let's say okay, for now let's transfer the entire amount, and the entire amount would be balance of this smart contract. Are you getting what we are doing? the entire amount would be balance of this particular smart contract. So, but in an ideal case, we never want to do that. Okay. Or we could also write like this: address of this dot balance. So this will give us balance of this particular address. Okay, but in an ideal world, we don't want to do this. We want to withdraw specific amounts, and we want to make our smart contract in such a way that all the parties involved get equal share. Okay, let's say in NFT project, there will be a development team, there will be a marketing team, there will be a blockchain developer, and me being an honest person, what I want to do is I want my smart contract to make sure that I pay equal amount to everyone, equal pay share to everyone. Doesn't matter how much whatever I do. But whenever I withdraw, a certain amount should go into all the address. Let's say we want to give 5% into designer, 5% into marketer, 5% into community manager. So you don't need to trust me. You will just add it into smart contract and say that, hey, we have done this thing. So how will we do that? Let's just understand that right now. Okay, let's say percentage. So let's have a UN. And let's say owner underscore percent. So this will define percentage of the what are percentage you want to give to this particular owner. So now, so how will it look now? It will be something like this. Okay, let's first calculate the amount. Transfer underscore amount equal to. Firstly, we'll take this address dot this address dot this returns the address of this smart contract, and then when you write dot balance, it will give you balance of this smart contract, right? Now what we want to do is, what are the amount we received? We want to multiply it with owner percentage. Let's say percentage is 5. Let's say 0.05. We'll just in our smart contract we'll define 0.05. So owner percentage into owner percentage. So now what does this mean? This means that whatever the balance amount of this smart contract is, I want to multiply it with 5%, and the 5% of it I want to give to Solidity to address owner. Okay, let's just change from owner to okay, let's keep it owner for time being. Let's not just confuse ourselves. Okay, this is owner. So now what we'll do is, now we'll transfer this balance from our smart contract to the owner's account. So for that, what we'll do is we'll do owner. Okay, let's make this payable, because payable, just to make sure that we could pay to this account. So owner dot transfer. Let's say transfer amount. That's it. So now what will happen is, whenever we withdraw the amount will be withdrawn. 5% of it will be withdrawn to this, but what are the percentage we define will be sent to this particular address. So likewise, you could have address 1, address 2, address 3, address 4, and a set percentage is stored. So whenever this function is called, those amount will be distributed on its own. So there's always fair distribution. So right now we have kept it public, but ideally you keep it only owner. Okay, I'll tell you what only owner is. Only owner means whoever deploys the smart contract, only they can call this function. And that makes sense, right? Because if anyone could call withdraw function, then what's the point of blockchain? What's the point of having the smart contract? So now what we'll do is we'll deploy our smart contract. And to deploy, what we do is firstly we compile. So it's compiling. So we haven't got any error. So compiling is safe. So now we go to run. Over here, instead of injected web-free, let's just have JavaScript VM. And these are the basic addresses that your Remix platform gives us to play around. So let's just deploy this smart contract. From here, we'll select our smart contract as MoleNFT. That is what it is, right? Yeah, MoleNFT. So let's just deploy this. Okay. So while deploying, we got all these functions. So now remember, we have not implemented these many functions, right? How many functions have we written? 1, 2, 3, 4, 5, 6. Yeah, 7 functions we have written, but over here there are this many functions. This is because we are inheriting from all these smart contracts, from ERC721, enumerable, URI storage, ownable. We are inheriting. So all the methods, all the functions over there will also be inherited in MoleNFT. So now what we do is we say mint NFT. Okay, so let's go to mint NFT function. Here it is. Over here we'll give addresses. Okay, number of mint, let's say 2. Number of address. Let me just copy any address for now. Okay, this one. Okay. This address and URI, let's say moledao.com. For now, let's not go to URI part, and we'll give value, right? So we are minting for 2 NFTs. So what should be the value? 0.2 ETH. So instead of okay, let's say over here, let's change it to Ether, and then let's write 0.2. Okay, let's just say 1 ETH. Yep. Okay, it won't accept in decimals. So yeah, for now, let's just say 1 ETH. Okay, over here, let's make it 1 ETH. So it's simple. We don't go into details of how we pass this thing. So we'll deploy it again. Okay, what happened? Failed transaction. Okay, it's because I gave you, yeah, okay. So for now, let's compile and then let's run. Okay, this is it. MoleNFT 0 deploy. So it's deployed, right? So whenever we deploy, we'll get our smart contract over here. Yeah, so now mint NFT, let's just add values. Number of mint, let's say 2, to address, this is the address, string something. And value will be 2 because we are asking for 2 NFTs. So now let's say transact, let's see what happens. Mint price not matching. Okay. So why do we get this error? Because we are over here, we are saying that message.value equal to mint price. But ideally, what we want is message.value into number of mints, right? Because previously we didn't have number of mints. After that, we added this function called number of mint. So now we need to multiply our message.value also, right? So now let's again deploy it. These are the small things that happens, right? These are the things that you miss when you deploy a smart contract. So let's say 2, again address, string something, value again 2. So now it should run. Okay, we again got an error. mint price not matching. Okay. So what now? Oh. Okay. So yeah, sorry, I just misunderstood. So what we are doing is message.value is already 2 Ethereum, right? But it is not matching with mint price. So now what we want is mint price should be multiplied with number of mints, not the message.value. Yeah, this should be multiplied with number of mint. Yeah, all right. Now it should run. Deploy. Two addresses. This one string is something. Let's say 2. Let's transact. Okay, it is minting. Okay, invalid address. Why is this invalid? Let me copy it again. Okay, so yeah, this shows us that the NFTs are minted. So now you will see that from this address, 2 Ethereums are withdrawn. Okay, this is because we used 2 Ethereums, right? Are you getting the logic now? As we minted 2 Ethereums, we used 2 Ethereums to mint. From this, 2 Ethereum are withdrawn, and now let's do withdraw function. Okay, there is withdraw function. So ideally, it should be that only owner should be able to do this. So let's just say owner. Let's have our address copied. Where withdrawal mint amount. Go here. Let's say address, and let's say I want to have 50% of the mint. Okay, so I'll say 0.5. This means that we are giving 50% of the mint to owner, and 50% is still with the contract. So when I transact, okay, what happens is error invalid big number string, invalid argument. Okay. We will need to give a whole number over here. So let's do it again. Okay, this is how we do it. Into percentage divided by 100. Okay, so these means this is 0.05. So now we'll send a whole number over here. Okay, let's do it. Let's deploy it again. Deployed. Now let's mint it again. Okay, let's use another address. This one. Copy to address something value to now transact. Okay, got minted. Now let's try to withdraw it. For withdrawing again, we'll use our parent address. This one, copy it, owner. Then over here we write 50 now, 50% because. So see, it got a transaction is successful. Now let's see the amount. Okay. So let's try to withdraw 50% to this address. Right now there are 96 ETH. So let's say we want to withdraw, transact. okay, caller is not the owner. Getting this, why this thing happened? Because this address is not the owner. That's why they can't just withdraw this amount. So this is how your entire smart contract works. So going forward, what you could do is you could have multiple conditions over here, that if address one, let's say this particular address will get 5%, this address will get 10%, another address will get 30%. So how do you implement that? Okay, let's just do a small demo. Address table ADR1, and then let's say UND ADR1 underscore percentage, right? So now over here, what we'll do is we'll copy this entire thing. Okay, let's not copy, let's write it. UND, let's say ADR1 underscore amount equal to address of this dot balance into ADR percentage divided by 100. So this will give you the percentage amount. And now let's say ADR1 dot transfer ADR1 amount. So this is how you do it. So this is how you create an entire NFT smart contract. What we did in this smart contract, we had a mint price, we had a maximum supply, we had individual supply. Then while minting, we checked that whether the message.value, that is the transaction amount, is equal to the mint price into number of mint, that is the requested amount. If yes, then go ahead. If no, then throw this error, mint price not matching. Then next we check that number of mint plus the total supply is less than max supply. So that we check that what we are asking for, we already have those, we are already allowed to have those number of mints. Let's say there is 99 out of 100, 99 NFTs are minted, and we request for 5 new mints, then that will be rejected, and you'll have an error that requested more than available NFTs. Then the third condition is balance of this address is less than individual supply. So that means that this address, whatever address is requesting, has minted NFTs which are less than the individual supply. If every individual is allowed to have 5 NFTs only, then if someone is requesting for more than 5 NFTs, then that request will be rejected. So this is what we check over here. Then we wrote a for loop where we are minting all the NFTs one by one by using SafeMint function. There are other things also which we could do, but for now, let's stick to SafeMint and let's not go to complex things. Then we have a withdrawal function where we defined that, hey, what are the number of, what are the percentage I want to give to certain persons that will be distributed evenly. Like even if owner wants to, he can't give 100% to himself. If he has promised someone that you will get 5% of it, they will get it. So this is it. Like this is how you mint your basic NFTs and you write a smart contract. So if you have any questions now, you could go and you could ask in the comments. And hey, anyone, YH, could you please, if you could see the comment section, could you share some of those questions here, if possible?
Sure. Actually, I have put in the Zoom chat. Do you prefer if we read out the questions?
Yeah, it will be great if you just speak out those questions.
All right. So there is a question from PB. Is there a checklist of functions to include for a basic NFT minting smart contract? Because in this session, realize you shared a few functions, so some of them are curious. Like they don't know what to include in a smart contract, like any checklist of functions?
So checklist, it depends on the utilities of your smart contract. Like what all utilities you want in a smart contract, you first decide those utilities, that this is how I want my NFT to function, and after that you implement all of those here. So there is no checklist as such in general, but in general we have these basic things. Okay, these are the common things that will be there in all the NFT contracts these days.
Cool. Thanks for sharing. Yeah. So another question from 0x. Can we update the smart contract once deployed? Because let's say we put the max supply 100 and then we suddenly want to change to 200. So is it possible to update the smart contract?
Yeah, in that case, we don't update the smart contract, but what we do is we have a setter function. Okay, so how does that setter function works is, let me show you. Just a minute, I'm just plugging in my laptop. My battery is down. Yeah, all right. So let's do that. Okay, so what you do is you write a function, let's say function set underscore max underscore supply. So what you take input over here is uint of underscore supply. Let's make it public. Ideally, it should be only owner. That only owner could call this function. So what you do over here is you set your max supply equal to underscore supply. So when you call this function, okay, what's the error? Instrument not visible. Okay. Yeah. Okay. So what we do is now whenever we want to update our smart contract, we'll straight away call this function set max supply, and now you could add. Okay, let's just do it instead of talking. Let's do it. Okay. Yeah. Let's close this one. Which one was it? Let's deploy it again. Here it is. So now if you see, where is it? What was the function? Yeah. We have this function called set max supply. So what you could do is you could write 200 over here, and you could say transact. And now it is executed. And now if you have a getter function, okay, let me have a getter. Okay, let me just make it public. Yeah. All right. So now when I'm clicking on, where did it go? Set max supply. Let's say I'm doing 200, transact, and then max supply. Where is it? Yeah, over here, max supply. So now you see max supply is 200. Getting this? So now if I am changing max supply to, let's say 500, and if I transact, and now if I call max supply, you will see it is 500. So this is what we could do. But then you need to see that you are changing all other variables also. When you are doing a setter function, you are carefully doing it. You need to check that. I hope that answers.
Awesome. Thanks, Raj. Let me see. There is a few more questions. So to deploy a NFT smart contract, typically how much does it cost in gas?
To deploy this simple smart contract, it will cost you around 0.3 to 0.4 ETH, but it depends on the complexity that you do. Okay, like this is a basic smart contract. It will cost cheap. It will be cheaper comparatively. It will be cheaper. But if you are if you are adding too much of functionalities, too much of features, then it might cost more.
Awesome. Thanks, Raj. I think we are running a bit out of time. So let me just pick maybe one or two more and then we can call it a day. If any of the developers here, you are interested to learn more or you are a bit confused, feel free to go to Questbook community as well, because they do provide a lot of resources for developers to learn Web3, to learn more as well. So let me just pick maybe one or two more questions before we end it. All right, so one is about the different blockchains. Is it better to deploy on Ethereum or alternative chain because of gas fee?
Yeah, I got the question. I lost it, but I got the question. It is Ethereum is the primary chain for NFTs right now. That most of the volume of NFTs is on Ethereum. But you could use this smart contract to deploy on any EVM compatible blockchain. You could use it to deploy on Polygon also. If you want to have an NFT drop on Polygon, you could just change the from here. You could just change the environment, injected Web3. Okay, right now I'm connected to Rinkebai. If I deploy this, it will be deployed on Rinkebai. But if you want, you could just change the network from your smart contract from your MetaMask, and then deploy your smart contract over there. It's easy. You could deploy it on any EVM compatible blockchain.
Great. All right. Last question that we picked out: how to mint on-chain NFT? Because what we see here is a URL of the NFT. So how do we actually mint NFT on-chain instead of just a link? Is there any way to do so?
Yeah, with on-chain NFTs, there are two ways to do this. One is creating on-chain SVGs. Okay, that is, you might have seen this project called Loot. Okay, Loot NFT. This is an on-chain. This is on-chain SVG creations. Okay, where is it? Let's just go to OpenSea. And another way is you could have pre-uploaded NFTs on your IPFS or anything, and then we could use those. We could use those URLs. But yeah, you need to upload your NFTs beforehand. You need to have that URL. The only other way is this. These are on-chain SVGs. They didn't have any previous database. These images were created while minting. You could check the smart contract. Will pretty much understand how it works. But if you don't understand it, you could always ping me on Discord or on Twitter. I'm active on both of these social medias, so feel free to ping me with all the doubts you have.
Awesome. Thank you so much, Raj. Thanks for the sharing. I think today's sharing, we are doing it with the purpose of current developers who already know Solidity to get a refresher of, the key functions and everything. But I understand that some of you here, you may be new to Solidity and maybe you got lost a bit. Don't worry, because actually Questbook has a lot of great resources. So if you're interested to learn more or, learn more basic on Solidity, feel free to go to Questbook website to learn from their resources as well. And like what Raj says, if you have any questions, feel free to reach out to him on Discord or on Twitter. And if you are here already very excited to build, feel free to check out Moledao's NFT 2.0 hackathon, because currently it's running and we have over, I think, 50 to 60,000 in prize pool. So it will end in about 2 weeks. Still have time. If you are keen, please click on our description on YouTube. Join us on Discord to participate in the hackathon. Awesome. So Raj, anything else to add? Or do you have words of encouragement for builders in this space?
That was pretty much it. If you have any doubts, reach out to me on social medias. Join Questbook if you want. You could go through this website called openquest.xyz. You will find all the resources over here. Like you could build on Ethereum, on Polygon, and if you go inside these courses, there are multiple things that you could learn other than NFTs. And apart from this, if you like this session, give us a shout out on Twitter. Thanks to Moledao, thanks to YH for organizing this session. Give us a shout out. Okay, people love this appreciation and love. So yeah, that's it. See you all in next session.
Awesome. Thank you so much, Raj, again for taking the time for this sharing. Really appreciate it. And thanks for helping to build Web3 as well, because now Web3 pretty new, so we are all trying to help and build a community. If you want to learn more, feel free to also check out Questbook for free and quality developer resources.
Yeah.
Awesome. All right. Thank you so much, Raj. And we'll see everyone on Discord if you have further questions or you want to catch up with Raj as well. Awesome. Thank you so much. And then have a good night. GN, everyone. Bye.